Hi guys, welcome back to Calculus with Mr. Robeson. Today we are looking at the third part C of section 1.3, limits. We're going to look at indeterminate forms, or one particular indeterminate form today. We'll go over what indeterminate means too. All right, so we'll get right to it. So finding limits analytically, so that means using algebra. So algebraically, so factoring and canceling, all that sort of good stuff. So often we'll be interested in finding a limit when the limits initially go to the form 0 over 0. So the top goes to 0, the bottom goes to 0. Now we don't want to write this on the AP exam. Don't write 0 over 0. They will not give you any credit for writing that as an indeterminate form. All right, this is called indeterminate. All right, since the top of the fraction, 0 on top of a fraction, says that the answer should be 0. But if we have 0 on the bottom of a fraction and a number on top, that tells us the answer should go to infinity. All right, so if we took just 1 over 0.000000001, like something that's going to 0, this goes to a big number. All right, so when we get 0 on the bottom of the fraction, an answer goes to big numbers. 0 on the top of a fraction tells us we go to 0. So between the two, they're fighting over which way it should go. So we're not sure what to do. All right, now if we do get 0 over 0 as a limit, what we want to do is we want to write out that the limit of the top goes to 0 and the limit of whatever's on the bottom goes to 0. So then we say indeterminate. We don't even need to write out the whole thing. And then we need to do something else, like maybe factor or try to rationalize the bottom, top, and bottom, simplify some sort of way. Later on, we'll have some other method called L'Hopital's rule. But right now, we don't know what that is. It involves derivatives, so we're going to just try and factor. And usually, we can do that with factoring. All right, but again, on the AP exam, we don't write 0 over 0 for free response. We write the limit of the top goes to 0, the limit of the bottom goes to 0, so it's indeterminate. They're very nitpicky about that. All right, so let's take a look at this guy. We want the limit as x goes to -2 of x to the third plus 8 over x plus 2. If we plug in -2 here, I'm getting -8 plus 8. That's 0. If I'm plugging in -2 here, I'm also getting 0. So you can write that out if you want. If it's the free response on the AP exam, you probably want to write that out. And we're going to -2. That equals 0. And the limit as x goes to -2 of x plus 2 equals 0. So it's indeterminate. So now what we're going to do is we're going to factor the top and factor the bottom. So this is the sum of cubes. So we've got x cubed plus 2 cubed. That equals, well, the first set of parentheses is we drop the cubes. Second set of parentheses is we square the first guy, switch the sign, multiply them together, 2x, and then we add and we're squaring the last guy. So there is the top. Our bottom is still x plus 2. So those two are going to cancel out. So now we try and take the limit again. This is where our problem was, because if we plugged in -2 here, that was 0 over 0. So we have canceled out 2 zeros. So the limit as x goes to -2 of x squared minus 2x plus 4. That's just a parabola. It's a polynomial. It's continuous, so we can just plug in. We're getting -2 squared minus 2 times -2 plus 4. So that's 4 plus 4 plus 4 gives us 12 as our limit. So that guy just gives us 12. All right, and if we take a quick look at the graph, so let's see, we're going to -2. So here's -2. We go up. Oh, look, that's a big old hole. Your calculator did not like graphing that one. All right, I believe I was counting by 3's here, so if I go straight over, sure enough, that looks like we're at 12. All right, so graphing is a good way to check your answers. All right, so again, if we plug in -3 here, that's -9. Or sorry, that's +9, -3, -6, so that's going to be 0 on the top. That's going to be 0 on the bottom. It's indeterminate. So we need to try and factor. So we've got x squared plus x minus 6. We want to factor that. I don't know if you guys are still drawing boxes and diamonds, but there is a faster way. Bring down the first sign, Plus and a minus makes a minus. We want factors of 6 that will subtract to make 1. That's 3 and 2. 3 times 2 is 6. 3 minus 2 is 1. 3 goes first because it's bigger. There's our factored form. Our bottom is still x plus 3. Those two are going to cancel, and that's good because that's where the 0 was. So now we just want the limit as x goes to negative 3 of x minus 2. So we get negative 3 minus 2 is negative 5. I don't remember if I put a graph here. Yep, there it is. And, well, it's right on the negative 5. So here we are at negative 3, negative 1, negative 2, negative 3 right here. We go down to our function. Yep, it's a whole. If we go over here, that's negative 1, 2, 3, 4, negative 5. Yep, that's the same thing we got, negative 5. All right, rationalizing. So hopefully in pre-calc you did something called rationalizing the denominator. It involves multiplying by the conjugate. The conjugate is just we take the whatever between them and switch the sign. That's the conjugate. All right, so if we do try to plug in 0 here, we get the square root of 1 is 1, minus 1 is 0. If we plug in 0 here, we get 0. So we have 0 over 0. That is indeterminate. So now we're going to multiply by the conjugate, and anything we do on top, we also have to do on bottom. So the conjugate of this guy is the square root of x plus 1 plus 1. So all that changes is the sign here between the root and what's not in the root. All right? And anything we do to the top of a fraction, we also have to do the bottom of a fraction. All right, you may want to try and cancel out here, but that would bring us right back to what we started with. So don't cancel out. All right, the whole point was we didn't want to cancel. What we want to do now is multiply these two guys out. And I know you're thinking that, oh, that looks awful. All right, but they're just going to cancel out the middle term. So we're going to get the first guy squared. So x plus 1 squared is just, or the square root of x plus 1 squared is just x plus 1 minus 1 times 1. All right, the middle terms would be negative square root of x plus 1 and plus square root of x plus 1, they cancel out. So the top is just that. Our bottom is still that whole thing. Don't do anything to it. Just leave it like that. There we go. Here we've got a plus 1 and a minus 1. Those are going to cancel out. We're just left with x on top. Well, now this x and that x can cancel. Everything on top is canceled. Technically, we divided here, so that leaves us with a 1 on top. On the bottom, we've got the square root of x plus 1 plus 1. All right, we canceled out x, and if we plugged in 0, that was a 0 over 0 that we canceled out. So now let's plug in 0 again and see what happens here. So we get 0 plus 1 is 1, square root of 1 is 1, 1 plus 1 is 1, or sorry, 2. So we get 2 on the bottom, 1 on the top, so our limit looks like it's going to be 1/2. All right, if we do graph it and check, there's 1 right up there. We have a hole right here, which was where 0 was, but that sure looks like it could be 1/2. All right, give this one a try. If you need to pause the video, you can pause the video. It does involve some factoring. All right, so if we redo this, let's switch colors. All right, so if we plugged in 3 cubed is 27. 27 minus 27 is 0. 3 squared is 9. 9 minus 9 is 0. It is indeterminate. All right, so we want to try and factor. All right, this is 3 to the third. So this is the difference of cubes. So that's going to be x minus 3, x squared plus 3x plus 9 by our formula. This is x squared minus 3 squared. So this is the difference of squares, which will factor into x minus 3, x plus 3. And look, there's x minus 3 on top and bottom. That's going to cancel out. And that was our 0 over 0 that we just canceled out. So now let's try and take the limit again here. So if we plug in 3 here, we get 9 plus 9 plus 9 over 3 plus 3. So that's what, 27 over 6. what did I say the answer was here? 4.5. All right, so I guess that works out to 4.5. Yeah, that looks like 4.5 to me. Let's see, cancel out a 3 from each. It'd be 9 over 2. Yep, 4.5 will work. Voila. Math. It's fun. All right, so that was limits with indeterminate forms, and really the only indeterminate form we looked at was 0 over 0. There will be others later, and we'll learn some shortcuts for this. All right, there is now a homework assignment on Google Classroom, so do your best to get that done and have questions ready when you come to class next time. All right, bye.